Okay, ladies and gentlemen, we've talked about finding real zeros of polynomials. Now, real zeros can be found by various factoring methods. So if I have an example, something like this right up here, this happens to be quadratic, power of 2. We have a number of ways to solve something like this. I could break it up, parentheses, 3xx, 5 and 1, works it all out, set each piece equal to 0. And solve it away. Make sure it's good. Alternatively, if it weren't something that were factorable like this, any quadratic equation can always be solved using the quadratic formula. So if we take the quadratic formula, plug it all in, we'll come up with negative 8 plus or minus 2 all over 6, and you're going to get two answers here. You're going to get negative 10 over 6, and you're going to get negative 6 over 6. And so it's going to work out. You're going to get two solutions. Now, do remember as a point of note that if you have a negative underneath the square root, then that means you're not going to have any real solutions. So real solutions would be things where you turn into numbers. Even if there's a square root in them, square root of 5, square root of 7 is fine. But as soon as you get the square root of negative something, then it becomes imaginary, and that's a problem. So, what happens when we go to a cube, though? Now, in some cases, if we have a cube, we can do this little trick. F of x equals x cubed minus 2x squared plus 4x minus 8. And if we take something like that, we can break it up, parentheses, x squared, x minus 2, plus 4 times x minus 2. Pull out x minus 2, leaving x squared plus 4. I have x equals 2, and x equals plus or minus 2i. So again, we have a trick like this. It's a third power equation, which means we have three roots. The problem is only one of those three roots is real. Then two of them are imaginary. Remember, imaginary roots always come in pairs. We're going to have a little theorem about that later. But what if I have something like this? This, I cannot use my little trick. I can't use the quadratic formula. I'm kind of stuck. So what I need to do is figure out a way to begin solving this. One way is to just start guessing. I could start dividing and start guessing to figure out what the zeros are. Maybe 17. Is 17 a solution? And so you go through and you put in negative 17 cubed minus 7 times negative 17 squared minus 22 times negative 17 plus 8. And you work it out and see, does it work? Oh, no, it doesn't work. Okay. What about 4? Could I try f of 4? And you try plugging it all in. You say, no, I don't know if 4 works, yes or no. You try it over and over and over. The problem is there's an infinite number of things you could try. An infinite number of things to guess and check is not probably a great way to go. What I need to do is I need to come up with something that gives me a better option, or at least a smaller set of options, that if I use those options, I'm probably going to come up with the correct answer. To do that, what I'm going to need to do is make a list. Now, ladies and gentlemen, here's how it works. Take the final number, the number that is by itself. We're going to call that P. Going to take the leading coefficient, whatever it is. We're going to call it Q. So I have P and I have Q. And all of the solutions are going to be of the form P divided by Q. Now, it's not just going to be 8 over 3. That's not just going to be the option. There's other things that do. Just like up here in quadratics where you could have different factors of things. If this were a 12, maybe this is a 12 and a 1. Maybe it's a 2 and a 6. Maybe it's a 3 and a 4. In the same way, we're not just looking at P. We're looking at P and all its factors. So it could be 8. Could be 4. Could be 2. Could be 1. All of these things make 8. 2 times 4 is 8. 1 times 8 is 8. And it could be, just like up here, depending on your signage, they could be a positive 8 or a negative 8, a positive 4 or a negative 4, a positive 2 or a negative 2, a positive 1 or a negative 1. but that only takes into account the p's. So in this case, we have 8 over 3, 4 over 3, 2 over 3, 1 over 3. But 3 is not the only option for q. What times 3 is 3? Well, the answer is 1. So now I have more options. It could be plus or minus 8 over 1, plus or minus 4 over 1, plus or minus 2 over 1, plus or minus 1 over 1. And now I have a whole list of possible rational options. Now, rational meaning no square roots, rational meaning no imaginaries. So we have all these. You say, well, that's 1, 2, 3, 4, 5, 6, 7, 8. I really have 16 different options for what I might try in here. Well, first things first, 16 is way better than an infinite number. Additionally, if this were some sort of even number, maybe some of these reduce as some of these. In this case, all of them are potential options. So what you need to do is you need to start going through them. And we need to see, are they factors? Now, one way to see if they're factors is to plug them in and say yes or no. A better way to test it would be to use synthetic division. By using synthetic division, 3, negative 7, negative 22, positive 8. Not only can I see if this is a solution, but remember when I'm done, I'll know the next level down. Because if I can find one solution of a cube, that leaves a square. Well, squares I can break up all sorts of ways. So let's see if we can come up with something. I probably don't want to start with my fractions, because if I put an 8/3 up here, that's going to make a nasty synthetic division. Why don't I start with something easier? Let's start with 1. Bring down the 3. Get a 3, then a negative 4, then a negative 4, then a negative 26, then a negative 26. I do this and I come up with negative 18, and that doesn't work. Okay, let's try something else. 3, negative 7, negative 22, 8, and let's try negative 1. 3, negative 10, positive 10, negative 12, positive 12, 20. Nope, doesn't work. Neither one of those work. Okay, so we keep going and we keep trying to solve. The problem is I'm going to have to go through this 16 times. Well, that's better than infinity, but not quite good enough. Let's try something else. What I've done, ladies and gentlemen, is I've used my graphing calculator and I've plugged in my equation so that I can clearly see what's going on here. Well, it looks as if this graph crosses somewhere around negative 2, somewhere between 0 and 1, and somewhere around 1, 2, 3, 4. So now instead of having 16 different options to try, maybe what I can do is simply take 3x cubed minus 7x squared minus 22x plus 8, and I want to try to divide that by something a bit more useful. 3, negative 7, negative 22, 8, and I said, I think it was around negative 2, so let's try negative 2. So 3, negative 2 is so negative 6. That's going to be 13, negatively speaking. That's going to be 26. That's going to be 4. That's going to be negative 8. That gives me a 0. So I now have a solution. So by looking at my graph and choosing wisely from among the various options, now I can see that negative 2 actually is a graph or a solution that I have. So I have x minus negative 2, parenthesis 3x squared minus 13x plus 4. Well, at this point, now I have something that's squared. I can factor it using either setting up parentheses, 4, 1, negative, negative, and now I have all three solutions, and what I've done here is now I have linearized the function. Linearizing means each term is a linear equation. And now I have my 4 solutions I can solve. I can say, all right, I know it crosses at negative 2. I know it crosses at 1, 2, 3, 4. I know it crosses at up. There it is, 1/3. And so now I know it is an odd. It goes up. And so now I can clearly graph it. That is using potential rational solutions and using synthetic division to actually find the zeros of cubes that we couldn't otherwise factor to this point. So what I want you to do is I want you to give me all the p's and q's for the following problem. 6x to the 5th plus 3x squared plus 4x minus 7. Give me all the possible p's and q's. So give possible rational solutions. Give possible rational solutions. That's number one. Number two, I actually want you to go through and solve for all the possible rational solutions for 2x to the 4th minus 11x cubed plus 2x squared minus 44x minus 24. And you'll notice you'll have to do one set of synthetic division, get your answer, and do another set of synthetic division before you can get from x to the 4th to x cubes till finally you're down at x squared and can attempt to break it up. Those are your two problems. See what you can do with those right now.